All right, fantastic. So, LCHF, low carbohydrate, high fat, and it's very important to understand it's moderate protein. This is not an Atkins diet, which is a high protein diet. And it's a way of eating, the old sense of the word diet rather than a weight loss diet, because it has to be sustainable. What's it designed to do? It's designed to reduce the sugar in your blood. What does that do? That reduces your insulin response. So taking it one step further, if you put yourself into a fat burning state rather than a glucose burning state, that's what we call ketosis or a ketogenic diet. So it depends on whether you're metabolically sick or healthy, how much carbohydrate you can tolerate and keep yourself with normal blood sugars and not create these AGEs. Now, there's certain times in our life where we might want to put on a bit more weight. You're going through puberty, pregnancy, you need the extra fat stores for the growth of either yourself or the baby, so you might want to develop a little bit of insulin resistance during that time. But the rest of the time, you don't want to be. So the high performance group does need a different carbohydrate level, and we can talk about that afterwards. But at the moment, you really need to think of an athloid. Who's an athloid? I'm an athloid. I'm not an athlete. I exercise 2 or 3 times a week, and that's the sort of person that we're talking about here. So these numbers really are a guideline only. Some people will need less than 20 grams a day to get into a ketogenic state, but some people will need as much as 50 grams and still be able to stay ketogenic. But for the most part, it would be hard to eat more than 50 grams a day if you're not doing significant amounts of exercise and stay in ketosis. So the question is, why has it become necessary for us to eat such a radical diet? Everything that we've been taught for the last 50 years, we've got a food pyramid, you've got to stick to it, and now we're turning everything upside down. It's so radical. Well, it's not really. If you look back to what we were eating before they introduced the food pyramid, that's all we're doing is going back to that.
Why do we need to be?
That's another, we will come to that. All right? So the question is, why do we need to be in ketosis? And there are many advantages to being in ketosis, many advantages. So as I mentioned earlier, insulin's the main hormone we're concerned with. So what is insulin? Why is it important? Well, it's from the Latin word insula, which means island, and it's a peptide hormone released from the beta cells of the pancreas, and it's released in response to glucose entering the bloodstream. So we eat the sugar over here. The sugar goes into the bloodstream, goes past the pancreas that senses what's happening. The pancreas releases insulin, and the insulin then drives the glucose into liver, muscle, and fat cells. Now, it helps all of these create glycogen, which is the storage form of glucose. Now, cell membranes are very complex structures. You have to think of them like the wall of a fort. They're designed to keep things out and keep things in. If you are like the wall, you can go through it, but if you're not, you can't get through it. And glucose is not like a cell wall, so it has to have a door open for it to get in there. And what's that door? It's called a GLUT4 transport mechanism, and insulin happens to be very good at opening up the key to open the door for the GLUT4 to activate and get the glucose into the cell. So it drives the glucose out of the blood into the cell, and as I said, mainly skeletal muscle, liver, and fat cells. But this cell wall is made up of the fats that we eat. So if we eat inflammatory fats, we're going to have inflamed cells. If we eat non-inflammatory fats, we're going to have less inflamed cells. So this is a glycogen. If you've not seen a picture of glycogen before, you need to think of the glycogen as the kitchen cupboard. So if you're hungry, you just open the kitchen cupboard, you take some food, and you go to the shops and you fill up that kitchen cupboard. Now, as long as you're eating what you're burning, everything's great. But what happens is, if you eat more than what you burn, your glycogen overflows. And it's got to go somewhere. It has to go into another room because the kitchen's full. What's the other room? The other room is your fat cells. All right? So the more glucose we eat and the more glucose we don't burn, the more we need to store and the more it becomes fat. Now, this wouldn't matter if you're on a low-fat, high-fat, any type of diet. If you eat more than what you're burning, you're going to store it as fat. So this isn't an all-you-can-eat diet. So this slide looks pretty complex, but don't worry, we're going to go through it bit by bit. This indicates a blood vessel on the outside of the fat cell, and this indicates the fat cell. So we've eaten the sugar. At this point, the body's still in emergency mode, trying to get that sugar out of the blood. And where's it going? Well, our liver and muscle glycogen stores are full. So where does it go? It goes into the fat cell. This is mainly the fat cells around your abdominal organs and the liver. So when insulin comes into contact with the fat cell, that's the scientific name of which is an adipocyte, it has two powerful effects working at the same time. Number one, it prevents it from getting any smaller. It stops you burning the fat. And number two, it stimulates more fat storage into the cell itself. So it's almost impossible as an adult for us to make new fat cells. So for the glucose to be stored, our fat cells have to get bigger. And this is weight gain. So, as I said before, you can't eat as much as you like regardless of what diet you're on, but we have to think about what makes us hungry. So why is it that wild animals aren't obese? When's the last time you saw an obese lion or giraffe or zebra? The body has a very complex signaling system which tells you when you're full and you no longer need to eat, so you don't need any more food to fill your kitchen cupboards. So again, this is a complex slide. You don't really need to know the details. The main factors involved are insulin and leptin. We're going to leave out the other 5 factors for today. When leptin goes up, your body feels full, and it tells you you don't need to eat anymore. It also gives you more energy to go and do things. The problem is that leptin is made by fat cells. So if you're obese, why don't you feel full? And why do you just want to sit on the couch? The problem, as I said, is leptin is produced but not sensed by the body. So the big problem in this situation is leptin resistance, or inability to sense the leptin, plus insulin has a very important effect here to block a lot of the positive effects of leptin. So if you've got too much insulin and you're leptin resistant, your body never gets a signal to stop eating. There are other factors as well, things like being taught that we have to eat 6 meals a day and having a whole lot of hidden sugars in our foods, which then stop us sensing that. So both glucose and fructose, which we'll come back to, override the feeling of satiety. So there's one situation in the wild where animals do become obese, and a bear is the best example of this. It wants to hibernate, so it gets fat before it hibernates. So what does a bear eat before it hibernates? Really ripe fruit, which is high in fructose or sugar, honey, and very high-fat fish and things like that. But it eats lots of fruit and lots of honey to last it throughout the winter, so it gets fat and then it burns the fat. So if you want to get fat, you do what a bear eats. You eat what a bear eats, fruit and honey. So the problem with this is that we have a lot of sugar in our diet, and sugar is 50% fructose. So we're going to come back to that. So this is glucose, this is fructose. Sugars are simple molecules, and they have slightly different side chains. Table sugar is a combination of each of them, and this is a particularly dangerous combination. So what about complex carbohydrates? Everyone knows complex carbohydrates are good for you, right? Well, in fact, a complex carbohydrate is just a whole bunch of glucoses put together. You eat it, the body splits it, what has become? Glucose. So all you've done is eaten glucose in a slightly different format. Once it gets into your bloodstream, it's no longer a complex carbohydrate, it's a whole lot of glucose. So what you eat becomes that, and the same applies to low glycemic index foods. Even if it's absorbed more slowly because it's a low glycemic index food, it ends up as glucose anyway. So there we go, the whole food pyramid is put upside down. So what is a triglyceride? A triglyceride is made up of glycerol and 3 fatty acids, and that's what's inside our fat cells. This is a very big molecule which can't move in and out by itself. So if you put more triglycerides in, your fat cell gets bigger. If you take them out, the fat cell gets smaller. Again, a relatively complex slide. And what you need to understand here is triglyceride can be broken into different components by something called lipoprotein lipase. Glycerol can get into the cell by becoming glucose and reforming a glycerol inside the cell. And the fatty acid is the same as the cell wall, so it can just go straight through. Once it's inside the cell, the triglyceride forms, and now it's trapped. And the only way a triglyceride can get out of the cell is if it gets broken down by this enzyme here, hormone-sensitive lipase. So the combined effect of insulin is to drive stuff into the cell and stop it getting out. So insulin makes the GLUT4 transporter more effective and your lipoprotein lipase more effective. If we look at the out pathway now, then what we see is that hormone-sensitive lipase is blocked by insulin. That means you don't get any fatty acid breakdown. So to summarize, insulin increases the effect of lipoprotein lipase and blocks the effect of hormone-sensitive lipase, effectively increasing the size of the fat cell. And this comes back to our original slide. Do we want lots of insulin? Well, how much insulin do we need to stop fat burning and start fat storage? Very little. It only takes a very, very small amount of insulin to drop you from there all the way down to here in order to start storing fat rather than burning fat.